This Coke had been sitting in the freezer for a couple of hours, and I thought it was finally cold, but when I went to pour it into my glass, it started also kind of forming a slushy material. How is this possible, and how is it related to snowflakes? Stick around to find out. The last video you guys saw from me was about why do Christmas trees smell like Christmas trees. And today we're going to talk about snowflakes, another very wintry topic that also concerns the air or the atmosphere around us. Snowflakes are able to form when gas or liquid droplets of water high up in the sky, high up in the atmosphere, get really cold. And those really cold droplets condense into liquids, and then they start to gather upon a piece of dust, pollen, some sort of particle in the atmosphere, and as soon as they touch them, they freeze and ice crystals start to grow, and that is what is called a nucleation point for ice crystal formation. Let's back up a little bit and talk about why that happens. So absolutely pure water is really hard to actually freeze. So if you have water that's got no other things in it, it's just water, it's really hard for that water to freeze. In fact, it can actually go below the freezing point and still not become ice, and that is known as supercooling. So when you saw me at the beginning of the video take that bottle of Coke, it was really cold, it was below the freezing point, but it was still a liquid, and when I hit it on something or poured it or disturbed it, that's when it froze. So that is called supercooling, when something is brought below its freezing point, but it still hasn't actually frozen. In order to get something to freeze, you need a particle, you need a piece of dust, you need pollen, you need something for those ice crystals to start growing on and to freeze. And this is known as ice nucleation. Now, ice nucleation is a very wide subject. Scientists study it every day right now. They're out there, atmospheric scientists are out there studying it. I took an atmospheric science, aerosol chemistry science course in graduate school because that's what my research was on, and I think we spent like at least a couple of weeks just talking about ice nucleation in the grand scheme of the course. There were a lot of diagrams, there's a lot of things that affect it, but to just keep it short and simple, the humidity of the air, the temperature, the type of particle in the air, all these factors affect when ice is going to form, how fast it might form, and what shape it's going to form. All these different things have an effect, and if they change while the snowflake is forming, the way the snowflake is forming or the pattern of the ice crystals is going to change as well. No wonder every single snowflake is unique. So if you ever look at pictures of snowflakes, you may notice, hey, these are all very hexagonal in shape, and that's because my water molecule here, the orientation or the kind of angle at which our water molecule is formed, we have an oxygen and two hydrogens. When they start to become together and you have a lot of water molecules together, due to this angle between the oxygen and the hydrogens, it starts to form hexagonal shapes. So you're going to have a snowflake that's got six-fold symmetry. So when you have those really super cold water droplets up in the atmosphere, come into contact with a piece of dust, the pollen, any sort of particle, it will condense and start to form ice on that particle, and from there, more and more water molecules will be attracted to it and form a bigger and bigger ice crystal. This is the literal snowball effect that's going on to form these snowflakes. So today we learned a little bit more about snowflakes, why they form, why each one is unique, and it's all due to the atmospheric conditions that are occurring as they form, ice nucleation, and water's very unique structure and angle. Today's fun fact that I want us to rate on a scale of 1 to 10 is that one snowflake can contain on average 1 quintillion water droplets. So please drop that rating for the fun fact in the comments below, like this video, subscribe to my channel, tell your friends all about it, enjoy the snow when it comes if you're in an area that gets snow. I post on every Tuesday and Friday, and keep it sciencey. Oh, it didn't work. I made a mess. Oh my gosh, why is it so hard to breathe. Oh my gosh. Oh, that's a bunch of embarrassing footage. Alright, when I first opened this bottle of Coke, it was completely liquid. Or before I opened this bottle of Coke, it was completely liquid. And now it is kind of formed a slushy-ish material. If you're wondering how that's able to happen, stick around. Nope. Rihanna!